On December 9th, 3 Atlas carried life and dropped multiple fragments onto the Moon. 3 Atlas moved along an impossible orbit, plunging straight into the Moon, carrying an ultra-dense ice layer still surviving the impact and slightly shifting the Moon's orbit, triggering a megatidal phenomenon that quietly redraws Earth's coastlines. As the impact dust gradually dissipates, the impact crater reveals straight symmetrical fragments, accompanied by complex organic molecules resembling a biological scaffold. The James Webb Space Telescope records a thermal heartbeat repeating every 4 hours from the core of Atlas, along with radio signals responding to a sequence of prime numbers, a self-adjusting orbit and spectra suggesting the presence of rare alloys and quantum materials. The entire Atlas body operates like a resonant chamber, with a spiral core following the golden ratio opening a dark cavity that is always oriented toward Earth. Data show that Atlas carries traces of synthetic biology, a signal with a universal grammar signs of spacetime curvature, and an alien face hidden within the resonant structure. At the same time, its anti-tail non-gravitational acceleration, fixed gas jet's strategic orbit around Jupiter, and a propulsion system resembling an ion engine force the scientific community to treat 3I Atlas as the first representative of a class of guided interstellar objects. What do these unexpected actions of 3I Atlas really reveal? We will explore this together with the scientists right now. On the screen, 3 Atlas glided in a pale arc that refused to bend like the familiar comets catalogued for decades. When the curve was extended, the projected path of 3 Atlas intersected not with empty space, but with the quiet circle of the Moon. Radar pulses brushed across the surface of 3I Atlas and returned not as simple echoes but as a pattern that rose and fell in time. Every few hours, the reflected signal from 3I Atlas brightened, narrowed, then softened again, like a distant lighthouse turning slowly behind fog. Noise usually drifts and wanders, yet this rhythm settled into the data with the calm patience of something following an inner schedule. In meetings, the curve was labelled a thermal cycle, but on late shifts observers watched 3I Atlas breathe on the screen, steady and unhurried. An ordinary fragment should tumble, crack, shed random plumes, while the supposed fragment named 3I Atlas moved as though wrapped in an invisible brace. The more the orbit was refined, the more the Moon lined up with that descending trajectory, as if 3 Atlas were answering some distant instruction. By the time the final plot settled, the question was no longer where 3 Atlas came from, but who or what had written that path. The first full-scale impact run did not begin with drama, it began with a progress bar. On the cluster screens, the simulated mass of 3I Atlas slid along the plotted orbit and met the Moon head-on. The numbers that followed were almost impolite in their bluntness. 3 Atlas, treated as a solid body, delivered an energy release measured in millions of megatons of TNT. Crustal shock waves rippled through the lunar interior, heating rock-lofting dust, carving a basin that dwarfed familiar craters. In the Model 3 Atlas bruised the Moon so deeply that the seismic ringing would last for decades. Analysts tried smaller masses, lighter densities, softer angles. Each time, 3I Atlas still struck hard enough to register as a once-in-a-civilization event. An ordinary comet should have fragmented long before such an encounter, shedding energy in bits and pieces along its path. Instead, in every stable solution, 3I Atlas arrived as a cohesive projectile like a hammer that refused to splinter. Composition became the next line of attack in the analysis of 3I Atlas. Spectral data were fed into the models suggesting that 3I Atlas was not fluffy ice but hyperdense frozen material nearly twice the norm. When that density was folded into the equations, the kinetic energy climbed, but the survival problem grew worse, not better. A natural body that compact should have torn itself apart under previous tidal stresses. Atlas brushed past those limits as if unaware. Someone proposed a buried vacuum cavity, a shell of reinforced layers, a kind of internal brace hidden under the frozen surface of Atlas. No model fully fit the data, but each brought 3 Atlas closer to the unsettling category of engineered durability. In late-night notes, analysts wrote neutral phrases about structural integrity, yet the implication sat heavy behind every careful sentence. Atlas behaved less like debris and more like an object designed to arrive intact regardless of what met it at the end. Observers watched the final frames of the simulation, the Moon shuddering and settling into a slightly altered path. The code showed oceans on Earth rising a little higher with each tide as the legacy of 3 Atlas continued far from the impact itself. The moment of contact came without sound, a brief blossom of light where 3 Atlas met the moon. Telescopes saturated and then recovered, and in that quiet afterglow, new orbital elements for the moon began to arrive. The numbers looked almost trivial at first glance. The path of the moon around Earth shifted by a fraction so small it fit in a margin note, yet every recalculation pointed to the same conclusion: the energy that Atlas had delivered was now stored as a subtle change in eccentricity and tilt. The moon's familiar orbit had been nudged, and the nudge carried the fingerprint of Atlas. Tidal models were the next to be updated. Into those equations, the new lunar path of Atlas's aftermath slipped like a thin, precise key. What emerged on the screens was not a cinematic wall of water, but a quiet amplification woven through the ordinary tides. Under the influence of Atlas, high tides climbed just a little more than before, and low tides fell a little less. Oceanographers began to see patterns of resonance, places where coastlines and basins hummed in step with the new lunar rhythm left by 3i Atlas. In those regions, the legacy of 3i Atlas unfolded as layered surges, each one modest, all of them cumulative. Harbours that had been perfectly comfortable for decades now found their margins tested on certain nights and certain winds shaped by Atlas. The change was slow, but the imprint of Atlas was present in every extra inch of water. Researchers gave the phenomenon a name to make it manageable. The scientists called it hypertide, a tide stretched gently beyond its old comfort, a tide rewritten by Atlas. The models built by oceanographers and physicists showed years, then decades of coastlines breathing in slightly deeper drafts, river mouths reshaping wetlands, drowning and being reborn under the quiet pull of 3i Atlas. As the curves settled into their new forms, the moon circled on, and the work of Atlas continued in silence far below. Sirens did not begin because of 3 Atlas, they began because of numbers that carried the mark of Atlas. On shared dashboards, projected sea levels rose in narrow bands of crimson, along familiar coasts carrying the quiet signature of 3 Atlas in every curve. Evacuation protocols that had slept in civil defense binders snapped awake as planners studied the projections tied to Atlas. Messages moved through satellites and fibre, while emergency centres rehearsed old storm scripts for a new kind of swell born from 3 Atlas. Cargo ports prepared to lift containers, higher subway entrances in river cities grew temporary walls, and whole districts practiced the art of stepping back from the edge that 3 Atlas had nudged closer. From orbit, new satellites watched the first hypertide pass a long, slow exhale of water shaped by Atlas. Where models had warned, the sea climbed a little further inland, confirming that the small shift in the moon's orbit was very real, and that the influence of 3 Atlas had migrated from a crater to the shape of shorelines. When the surge finally retreated, cameras turned away from flooded streets and back toward the scar on the moon where 3i Atlas had arrived. The dust plume began to thin under harsh sunlight. High above the lunar horizon, imaging arrays focused on the impact basin that 3i Atlas had carved. What the instruments returned did not resemble a random spill of fractured ice from Atlas. Across the floor of the new crater lay shards with edges disturbingly straight, all traced back to 3i Atlas. Some fragments of 3i Atlas formed parallel ridges, others framed cavities with clean angles, as though empty rooms had been frozen inside the visitor. Shadow maps produced by lunar geophysicists hinted at repeating modules beneath the rubble patterns that natural shattering rarely produces once and almost never repeats, especially not with the scale associated with 3i Atlas. In preliminary reports, language stayed cautious, full of words like alignment and symmetry. In private conversations, the phrase-designed structure circled quietly, always paired with the name 3i Atlas. Teams drew up new missions, new probes, new lenses, knowing that the next phase would mean descending into the crater, and asking what exactly had survived inside 3i Atlas after the world had finished bracing for the tide. Years after the impact tide charts quietly recorded the handwriting of 3 Atlas. The hypertide that 3 Atlas had awakened no longer felt like an event, it felt like the new normal. Harbour masters learned a different kind of intuition. They no longer trusted old rules of thumb about where the highest water would stop, because the legacy of 3 Atlas had stretched every rule by just enough to matter. Coastlines did not vanish in a single catastrophe. They migrated inch by inch, following the small adjustment that 3 Atlas had written into the moon's path. Maps were redrawn with slow patience. Villages moved a few streets inland, dikes rose by the height of a hand, and wetlands expanded into spaces once marked as fields, all in quiet response to the distant work of 3 Atlas. From orbit, the changes looked subtle but stitched together. They traced a new contour to the planet, a faint outline labelled in technical reports as post-Atlas baseline. While the oceans adapted, another story unfolded on the Moon. Robotic landers descended into the crater of 3 Atlas, their feet sinking into glassy regolith fused by unimaginable heat. Drills bit into preserved fragments that still held the dense frozen material carried across interstellar space by 3 Atlas. In clean rooms back on Earth, those samples were dissolved, separated coaxed to reveal their secrets. Chromatograms displayed forests of peaks far more intricate than the simple molecules usually found in comets, suggesting that 3 Atlas had ferried something richer. The structures resembled scaffolds rather than complete organisms branching frameworks on which more familiar chemistries could assemble. Nobody saw cells' membranes or anything that could be called life, yet the precursors that 3 Atlas had delivered were so complex, so carefully arranged, that randomness felt like a thin explanation. Some researchers spoke of seed architectures as if 3I Atlas had been carrying blueprints, waiting for the right conditions to be filled in. Publicly, the language remained cautious, full of phrases like abiotic complexity and prebiotic potential linked to 3I Atlas. Privately, many of us understood that the discovery suggested a pattern older than Earth, a tendency for chemistry to reach upward whenever given the chance. As new coastlines settled into place and the Moon traced its slightly altered orbit, the thought lingered that 3 Atlas had done more than bruise a satellite. 3 Atlas had quietly reminded us that life, or the possibility of life, might be a habit of the galaxy rather than an accident of this shore. The more closely we examined the molecular forest that 3 Atlas had delivered, the less they resembled random debris. Each new analysis of 3 Atlas revealed branching chains folded into shapes that seemed to anticipate the chemistry of familiar biology, without becoming biology itself. Under high magnification, the scaffolds carried by 3 Atlas, arranged into repeating motifs like themes in a piece of music that has not yet found an instrument. Ratios between certain building blocks recurred with eerie consistency across different samples from 3 Atlas, as though some quiet rulebook had been followed. Map those patterns onto the old records of the rhythmic signal that had once pulsed from 3 Atlas before impact lining peaks and valleys against molecular structures. The timing in the signal from 3 Atlas began to look less like noise and more like a slow patient encoding of possibilities. One working group proposed that the signal of 3 Atlas was not a message in the human sense, but a kind of chemical metronome. In that view, the rhythm associated with 3 Atlas did not say hello or we are here. The rhythm simply stamped a template across space, a way of nudging chemistry toward complexity wherever the fragments landed. The idea felt strange at first, yet similar gradients and motifs began to appear in laboratory recreations inspired by 3 Atlas, as if the scaffolds were designed to respond to any hospitable environment. Reports avoided strong words, but conversations drifted toward the same conclusion. 3 Atlas seemed to behave less like a courier of finished answers, and more like a carrier of questions that chemistry could explore on any world. In that light, the presence of those precursors on fragments from 3 Atlas suggested that life, or something close to life, was not a rare exception pinned to Earth. Instead, 3 Atlas hinted that the universe might be biased toward organization, that given enough time and a few guiding patterns, matter tends to climb the same ladder. Looking at tide charts altered by 3 Atlas and at molecular diagrams annotated in quiet astonishment, many of us felt the same calm unease. The story of 3 Atlas no longer belonged only to the Moon and the seas. The story of 3 Atlas had slipped into the broader question of how often the galaxy tries to wake up. To follow that question further turned our attention back to the skies, where 3I Atlas had once glowed faintly in the sensors of a distant telescope, now watching other quieter stars. When astronomers first pointed the infrared mirrors of James Webb toward 3 Atlas, the detectors registered only a pale ember. Against the deep background, 3 Atlas looked like one more shard of cold matter, drifting through ordinary darkness. For several orbits of Earth, 3 Atlas behaved in the data exactly as the textbooks would have predicted. Then the temperature maps changed. Pixels near the core of 3 Atlas grew warmer, not in a chaotic flicker, but in a smooth rising swell. The glow from 3 Atlas peaked, softened and faded back down, while outer regions stayed almost unchanged. 4 hours later, the same pattern returned as though the inner layers of 3i at last were quietly rehearsing a script. Engineers checked calibration files, suspecting some slow mechanical cycle inside the telescope rather than inside 3i Atlas. When parallel instruments saw the same rhythm, the focus turned back to the visitor and to the strange regularity of 3i Atlas. Natural heating from sunlight should have produced broader, messier changes across the surface, not this narrow central pulse pinned to the heart of 3i Atlas. The anomaly grew harder to ignore as the days passed. Each new observing window showed the same 4-hour cadence, as if 3i Atlas were following an internal clock that cared nothing for viewing schedules. Graphs that should have been noisy turned into clean layered waves stacked one above another, all traced to the centre of 3i Atlas. In meetings, the scientists called the pattern a thermal oscillation, a harmless phrase that sat more comfortably than heartbeat when discussing 3i Atlas. Late at night, as the curves settled and rose in perfect order, many researchers felt a quiet unease around 3i Atlas. The next step was obvious and gently unsettling. If a rhythm lived inside 3i Atlas, then the sky now held a question that would guide every observation to come. The decision to speak to 3i Atlas began as a late suggestion on a quiet conference call. Instead of only listening to the strange thermal rhythm of 3i Atlas, one radio astronomer proposed sending a simple radio pattern into the dark. Arrays on Earth turned slowly, their dishes following the projected path of 3i Atlas across the sky. Engineers encoded a sequence of prime numbers, a calm universal ladder of values, and let the signal spill outward toward 3i Atlas. For long minutes, nothing in the telemetry changed, and the familiar heartbeat of 3i Atlas continued rising and falling every 4 hours. Data logs filled with the same smooth oscillations the teams had already charted, as if Atlas were unaware of any greeting. 72 hours after transmission, the monitors flickered with a new spike that did not belong to background space. A narrow band pulse arrived from the direction of 3i Atlas, delayed by exactly the travel time the radiophysicists had predicted. Within that pulse, the structure echoed the primes the engineers had sent, rearranged and stretched, but unmistakably related to the message aimed at Atlas. The correlation was high enough that chance felt thin, and every eye in the control room drifted to the line labelled 3i Atlas. Almost immediately, orbit analysts noticed that the projected path of 3i Atlas no longer lay exactly where the previous day's plots had placed it. The change was tiny but coherent, a gentle bending of the trajectory that carried 3i Atlas away from one corridor of space and into another. Models showed that random jets from a natural comet would have produced a jerky trail, while the adjustment linked to 3i Atlas was smooth and continuous. To generate such a shift without gassing alone would have required a torrent of material no telescope had ever seen streaming from Atlas. The simplest fit was that some controlled thrust lived within the strange visitor called 3i Atlas. No one wrote that sentence into the official report, but the idea hovered in the room each time new data for Atlas appeared. A shard of supposed debris had listened, answered, and then stepped slightly aside as though 3i Atlas had taken the call into quiet consideration. From that night on, every observation carried a different weight, as if the sky had moved 3i Atlas from the column labelled object into the column labelled presence. Spectral plots from 3i Atlas first looked like the usual forest of lines, dense but familiar. When analysts overlaid reference libraries on the data from 3i Atlas, the matches fell away faster than expected. Common cometary signatures appeared, but behind them, 3i Atlas carried absorption lines that refused to sit inside known catalogues. Some features from 3i Atlas lined up with alloys that on Earth belong to high-end manufacturing, where rare Earth elements are coaxed into precise rolls. Other features from 3i Atlas resembled theoretical quantum materials, substances described in papers but never confirmed in the wild. To test the pattern, spectroscopy teams converted the spectrum of 3i Atlas into sound mapping frequency to tone. The result from 3i Atlas did not resemble white noise. Chords emerged stable and repeating. At specific bands, the response of 3i Atlas rang longer than expected, as though a hidden lattice was storing and returning energy like a bell. Models of a simple rubble pile failed, while cavity models wrapped around 3i Atlas produced curves that hugged the measurements more closely. In those models, the entire bulk of 3i Atlas behaved as a resonant chamber, a single continuous structure rather than a heap of fragments. Low-frequency modes associated with 3i Atlas aligned suspiciously well with the 4-hour thermal rhythm already tracked from the core. To the physicists examining the graphs, 3i Atlas increasingly resembled an engineered instrument humming to its own internal clock in the dark, The same clock that warmed the heart of 3 Atlas seemed to be striking through the material frame as well. Technicians began to speak quietly about the hum of 3 Atlas, a vibration no ear could hear but every graph displayed. The more the data stacked up, the more 3 Atlas resembled an engineered instrument tuned to specific responses, not a random sculpture of ice and dust. With each new run, the question deepened: if 3 Atlas was built to resonate, what kind of message or function might that resonance serve? To look for answers, investigators turned from bulk properties to the geometry beating within the core of 3I Atlas. Deeper imaging pushed past the outer glow and into the heart of 3I Atlas. Reconstructed in 3 dimensions, the warm core of 3I Atlas resolved into a spiral, not a blur. Layer by layer analysis traced the curve and measured its proportions. Segment ratios inside 3 Atlas settled again and again around the golden ratio, not once but at multiple nested scales. In nature, that proportion appears in shells, storms and galaxies, but almost never as a clean repeating architecture buried inside frozen rock like Atlas. The more the team refined the model, the less the inner form of 3I Atlas looked accidental. Simulations showed the spiral inside 3I Atlas, rotating with a steadiness that ignored small perturbations from outside. Even when the overall body of 3 Atlas tumbled slightly, the reconstructed axis of the spiral remained eerily constant. It was as if an internal frame of reference were holding shape at the centre of Atlas, quietly resisting the chaos of space. Then, in a sequence of high-resolution frames, a different movement appeared on the surface of 3 Atlas. One panel-shaped region of Atlas shifted along a straight line, paused, and then folded outward like a slow, mechanical petal. Behind it, sensors glimpsed a dark rectangular cavity, an opening that swallowed incoming light with almost no reflection from 3I Atlas. Tracking software followed that exposed cavity as 3I Atlas continued along its path. Despite the spin and drift of 3I Atlas, the orientation of the opening kept relaxing back toward the same point in the sky. Calculations confirmed the alignment. The line from the cavity of 3 Atlas intersected the orbit of Earth again and again. On the displays, the hatch of 3 Atlas looked small against the backdrop of the stars. For many watching, the impression was simple and difficult to shake. 3 Atlas no longer seemed only to be passing through our system. Atlas was now facing us. When chemists peeled back the familiar lines of water and carbon dioxide from the spectrum of 3I Atlas, stranger signatures remained. Against expectation, certain emission bands from 3I Atlas matched the fingerprints of synthetic biopolymers first created in terrestrial laboratories. On Earth, those chains were designed as programmable scaffolds, half material and half code. Inside 3I Atlas, the same style of patterns appeared without any of the reactors or clean rooms that had birthed them here. Ratios between subunits in the chains carried by 3 Atlas repeated with a precision that suggested intention, not geological accident. The more carefully the teams checked contamination controls, the more firmly the signal pointed back to Atlas. Microscopy of recovered fragments revealed fibrils where mineral matrices and polymer strands interwove. In those hybrids, the rigid backbone of 3 Atlas supported flexible, information-rich branches, as if Atlas were built to both endure impacts and store instructions. The old boundary between hardware and wetware blurred inside 3 Atlas, until it felt artificial to describe Atlas as either machine or almost life. Meanwhile, orbital dynamicists followed a different set of clues. Tracing the incoming vector of 3 Atlas backward through time, they noticed that the line of approach from Atlas brushed near certain long-known structures on Earth and Mars. Ancient alignments of stone and bedrock carved by past civilizations seemed to point within small margins of error along the same great circles that 3 Atlas now travelled. On Martian plateaus, eroded ridges echoed those directions as though the sky path of Atlas had been sketched long ago into rock. Some called it pattern hunting, others called it gravitational memory, a faint record of previous passages left in architecture and terrain that predated any knowledge of 3 Atlas. If 3 Atlas was returning along an old route, rather than arriving for the first time, then the hybrid materials inside Atlas might also be carrying a history. That possibility left many of us looking differently at both the stones beneath our feet and the quiet arc of 3 Atlas still crossing the dark. In a final effort to understand the voice of 3 Atlas radio astronomers, designed an experiment that sounded almost like a paradox. Instead of sending a complex message toward 3 Atlas, the arrays broadcast a carefully shaped band of near silence, a wide, clean window in the noise. For long seconds after transmission, the receivers watched the region around 3 at last, and saw only the usual background hiss of the galaxy. Then the spectrum near 3 at last went unnaturally flat, as if someone had pressed a gentle finger against the fabric of space. Across that band, the usual static was suppressed not once, but for a measured span of just over 6 seconds, and the suppression tracked the exact direction of 3 at last. When the silence ended, a single pulse surged from the coordinates of 3 at last. Within that pulse, the frequency steps traced a familiar pattern, one that mirrored an enigmatic signal recorded decades earlier, now echoing through the behaviour of 3i at last. Analysts broke the waveform apart and found nested repetitions and mirrored sequences, as though 3i at last were arranging simple elements into layered self-referential phrases. Mathematicians described the structure as a kind of universal grammar, not tied to any human tongue, but to the logic of building complexity from a few basic rules. In that framing, the response from 3 at last was less a sentence, and more a demonstration of how at last could organise information. The pattern resembled the way living systems fold copy and refer back to themselves, though 3 at last remained far from anything we would comfortably call alive. For some, the experiment suggested that a latent awareness might live in the organised behaviour of 3 at last, an awareness expressed in timing and symmetry, rather than thoughts. Whether or not consciousness was the right word, the sky now held a presence that replied with structure whenever 3 at last was gently asked. The next anomalies would move beyond signals and into the fabric of space itself, as 3 at last approached regions where gravity and time could be measured with exquisite care. The first hints that 3 at last was touching space-time came from places that were supposed to be boring. Arrays watching distant guide stars noticed tiny shifts in position when their lines of sight passed near the path of 3 at last. The offsets were too small for the naked eye, but they persisted in stacked images that included 3 at last. Patterns of delay appeared in the timing of background pulses, as if the clocks of distant sources ran slightly slow whenever they shone past at last. Standard lensing calculations could not quite account for the way the light bent around 3 at last or for the asymmetry in how signals slurred in time. Modelers built simulations in which a compact mass inside 3 at last generated a pocket of exaggerated curvature. To match the data, the pocket had to flex and relax with the same quiet cadence that already defined the inner rhythms of 3 at last. In those scenarios, Atlas did not simply move through space. 3 at last carried a small region where time itself ran at a different pace. If the core of 3 at last experienced fewer seconds per orbit than the universe around it, then the journey of at last through interstellar distances changed character. 3 at last could cross what looked to us like ages, while aging less by its own internal measure, a traveller surfing gradients of time. The thought left some of us staring at the plots of 3 at last with a muted awe, aware that our own lives were being measured against a different clock. As the data accumulated, the question shifted from whether 3 at last bent time to what 3 at last might be carrying through that altered river. Answering that question would lead observers to look for shapes and memories written into the resonance of at last itself. A data sculptor took the resonance curves of 3 at last and poured them into a 3-dimensional algorithm, letting geometry rise from sound. When the model resolved, the inner harmonics of 3 at last converged into a shape that froze her hand above the controls. Across the virtual volume, bands of constructive interference inside 3 at last traced an outline that looked disturbingly like a face. The proportions were elongated, perfectly symmetrical, and utterly non-human, a mask emerging from the hidden frequencies of 3 at last. Analysts tried random phase tests and noise injections, but the facial pattern inside 3 at last kept reappearing whenever the true data were restored. Attention turned to the darkest region at the centre of the model, where simulations of light paths behaved strangely. Photons that entered this core zone inside 3 at last bounced through a maze of calculated reflections and refractions rarely escaping in the models. Mass estimates suggested more gravitational influence than the visible material of 3 at last could easily explain, as if extra volume had been folded inward. Some teams began to describe the innermost spiral of 3 at last as a vault, a place where information could be stored in trapped modes and looping rays. In that metaphor, the face woven into the resonance of 3 at last might not be a portrait, but a kind of label on the door of a memory chamber. The idea that 3 at last could carry a compressed archive of experiences or maps turned quiet interest into a more focused, careful watch. As plans formed for closer passes and continuous broadcasts, the approach of 3 at last toward the inner system began to feel less like a flyby and more like an impending encounter. As 3 Atlas slipped deeper into the inner system, the expectations were simple. Most comets flare briefly and then calm their light curves, smoothing out as geometry improves, but 3 Atlas refused that script. With each new night of observation, the image of 3 Atlas grew sharper yet less compliant. Brightness from 3I Atlas twitched in ways that did not track spin models or standard dust release. Instead of settling into a predictable pattern, Atlas accumulated small disagreements with every forecast we drew. Amateur astronomers joined the watch, turning backyard telescopes toward the streak of 3 Atlas. Their stacked images showed thin, rigid features and angular shadows that professional pipelines had smoothed away around Atlas. Reports arrived of a narrow sunward extension and an unusually clean central spine, all tied to 3I Atlas. Photometry teams adjusted exposure times, filters and reduction methods, suspecting software before suspecting Atlas. Each revision removed artifacts but left the same stubborn structured profile clinging to 3 Atlas. Parameters that should have converged towards stability refused to do so. Error bars narrowed while residuals around Atlas stayed oddly large. In briefing rooms, the word anomaly appeared more often beside the name 3 Atlas. The closer Atlas came, the more it behaved like a system with its own rules instead of a passenger following ours. Quietly, people began to admit what the plots of 3 Atlas already hinted. Something about this approach was not just brightening a comet, it was eroding our confidence that Atlas belonged in the natural category at all. Among the many strange details around 3I Atlas, one feature drew more disbelief than the rest. Extending from the core of 3I Atlas, observers saw a thin, bright structure, pointing almost directly toward the sun. In ordinary comets, dust and gas form tails pushed away from the star by radiation and solar wind, yet the anti-tail of 3 Atlas leaned sunward. Dynamicists tried to save the models by calling it a line-of-sight trick, but the viewing geometry of 3 Atlas refused that explanation. The Earth never crossed the orbital plane in quite the way required, still the apparent spear of Atlas held its alignment. To maintain such a feature, 3I Atlas would need to shed material at a staggering rate. Equations showed that if the anti-tail of Atlas came from natural outgassing, more than 1/10 of the total mass should already have vanished. At that level of erosion, the body of 3 Atlas ought to look ragged, fractured on the edge of disintegration, not compact and sharply structured. The paradox hardened with each new image of 3 Atlas. Either the physics of dust and plasma near a star needed rewriting, or 3 Atlas was sustaining the anti-tail by some other means. In corridors after meetings, people spoke softly about how the behaviour of Atlas felt, less like a leak and more like a directed beam. That quiet comparison would soon lead to even more uncomfortable questions about how 3I Atlas moved at all. The first hints of non-gravitational push from 3I Atlas slipped in as a small residual on an otherwise clean fit. For months, the path of 3I Atlas had followed gravity's script exactly, matching predictions to within fractions of a pixel. Near closest approach to the Sun, the orbit of 3 Atlas began to drift. A tiny extra acceleration appeared in the solutions, always nudging at last in the same sunward direction that the impossible anti-tail already marked. Analysts tried adjusting masses ephemerides and solar pressure terms, but the surplus shove linked to 3 Atlas refused to vanish. To produce that much extra speed through outgassing alone, 3 Atlas would need to vent a gigantic quantity of material. We had already assigned a similar mass loss to the anti-tail, yet 3 Atlas still looked whole. There was not enough observed debris streaming from Atlas to pay the bill twice. Rotation models deepened the problem. As 3 Atlas spun, natural jets should have swung in and out of view, modulating the thrust with a clear periodic signature. Instead, the narrow sunward emission associated with 3 Atlas remained startlingly steady, as though welded to a reference frame independent of the spinning nucleus. In effect, the exhaust of 3 Atlas seemed decoupled from the body, behaving like a fixed nozzle on a gimbal, rather than a crack in ice. That image made people uncomfortable because a gimbaled thrust suggests control, and control suggests design within 3I Atlas. With every new orbit solution, the category line wavered a little more, and 3 Atlas looked a little less like a comet, and a little more like a guided system passing through our star's domain. The projections that unsettled people most did not involve Earth at all. They involved Jupiter and 3I Atlas. When long-term trajectory integrators ran ahead, the pale line of 3 Atlas curved inward and brushed a very specific distance from the giant planet. That distance was not arbitrary. The plots showed 3 Atlas passing near the hill radius of Jupiter, the boundary where the planet's gravity can cradle moons and captured objects. For spacecraft designers, such a region is prime real estate, a place where a careful approach like that of 3 at last could linger for a long watch over the system. Independent teams reran the numbers. Their simulations, using different codes and assumptions, kept placing 3 at last within a margin so slim it felt like aim rather than coincidence. Discussion threads filled with quiet remarks about how 3i at last appeared to be setting up for a gravitational maneuver, not a random flyby. Then an official update arrived. Revised parameters from a major centre shifted the expected path of 3i at last just outward, pushing the encounter clear of Jupiter's Hill sphere. The justification spoke of better fits, updated photometry, improved treatment of non-gravitational forces acting on Atlas. Independent analysts repeated their own solutions and still found 3i Atlas dropping closer to the strategic zone than the new model allowed. In hallways and late-night calls, the spreadsheets took on a second layer of meaning wherever the name 3i Atlas appeared. Even if the published curve moved, the real motion of Atlas would settle the argument in the Jovian sky. Until then, the approach of 3i Atlas toward Jupiter felt less like a curiosity and more like a planned chapter we had not written. Whispers about propulsion began as an attempt to repair the numbers wrapped around 3 Atlas. If natural outgassing could not explain the smooth, persistent shove behind 3i Atlas, perhaps another known force could. Engineers started from what they understood best. They compared the narrow sunward jet of 3i Atlas with the exhaust plumes of electric and ion engines tested around Earth. Those devices trade volume for velocity, throwing a small amount of mass away at extraordinary speeds. When the team plugged such exhaust velocities into the equations for 3 Atlas, the mass requirement dropped to a plausible fraction. Under that assumption, the paradox of the anti-tail softened. 3i Atlas no longer needed to dissolve itself by 10% to maintain thrust. A thin, continuous flow from Atlas moving thousands of times faster than cometary gas could in principle supply both the non-gravitational acceleration and the rigid spear-like structure. Rotation remained the sticking point. On a natural nucleus, vents tied to surface patches would spin in and out of orientation as the body turned. Thrust from 3 Atlas, however, stayed locked toward the Sun with unnerving discipline, barely nodding as Atlas rotated. To reproduce that behaviour in the lab, engineers fixed their nozzles to stabilise platforms, a configuration uncomfortably close to what 3i Atlas appeared to be doing in space. One internal memo framed 3i Atlas not as a rock with leaks, but as a bus with engines. The bulk of Atlas became the bus, and the sunward jet, the adjustable drive steering 3 Atlas through gravity wells with deliberate economy. Official documents avoided that metaphor, yet once heard the image of 3 Atlas as hardware refused to leave the mind. The more the models converged, the less room remained between the behaviour of 3 Atlas and the phrase-engineered mechanism. Accepting that idea meant accepting that someone somewhere had once known how to build and launch something like Atlas. With Jupiter's domain approaching, the question shifted again. Observers now wondered what kind of mission 3 Atlas might be quietly carrying out as Atlas threaded the corridors of our system. To test how tightly 3 Atlas held its strange jet analysts stacked nights of images and mapped the spin of the nucleus. Surface markings on 3 Atlas traced a slow, steady rotation, a lazy tumble not unusual for a long-travelled fragment. The emission behaved differently. In composite frames, the bright sunward stream linked to 3 Atlas barely wavered, as though pinned to a separate compass. No matter how the mottled body of 3 Atlas turned, the thrust line stayed almost perfectly aligned with the star. The mismatch between moving shell and steady beam around Atlas grew sharper with every new stack. On a natural object, forces must ride with mass. Jets tied to cracks and vents should spin with the rock that hosts them, but 3 Atlas declined that rule. Modelers ended up treating the emission geometry of 3 Atlas as though it were bolted to an invisible frame passing through the core. In those diagrams, the frozen bulk of Atlas became cargo, while an internal scaffold carried the true reference axis and pointed the exhaust. The language shifted accordingly. Instead of describing 3 Atlas as a body with activity, some began to call Atlas a system with a body attached. That subtle inversion captured the feeling that control, not composition, lay at the heart of 3 Atlas. Accepting a decoupled frame for 3 Atlas meant admitting that the object behaved more like a stabilized vehicle than a spinning stone. From there, the next step in thought came quietly but firmly. Perhaps 3 Atlas did not belong anywhere on the old comet charts at all. and at last represented the first glimpse of a different class of interstellar thing. When all the reports were set side by side, 3A Atlas no longer fit inside any existing box. Taxonomies that once felt sturdy now bent awkwardly around the behaviour of 3E Atlas. Size, brightness and orbit could be forced to match rare comets on paper, but the inner workings of 3E Atlas refused the label. The thermal heartbeat, the engineered resonance, the guided thrust and the decoupled rotation each pushed at last farther from the word natural.